phagocytes, but their specific name, and depending on what they do, macrophage, big eaters, is what they are. So this is where we're at. Free macrophages, special free macrophages, alveolar macrophages, which is going to come up again in the lungs. And literally that's where we're at, but we're a little bit behind by a day or so. So let's push on. Movement and phagocytosis, all macrophages move through capillary walls. Okay? So they're moving around. We already know what positive chemotaxis or chemotaxis is, right? The response of white blood cells to chemicals. What are the two cells? What are the two cells that secrete histamine? Mast cells, fantastic. Basophils, fantastic, excellent. We're on top of it today. Woohoo! Okay, immunological surveillance, let's say in that word, immunological, because I can easily mess it up if it's not a good day, but today's a good day. Immunological surveillance is carried out by natural killer cells. They're part of our innate immune system. They're the ones that are going to kick it. Okay? Now, activated NK cells identify and attach to abnormal cells, non-selective. Okay? Vesicles release proteins called perforins. Perforins. How about poke a hole in? Does that help? Poke a hole in. Let's change the name from perforins to poke a hole in. But we could say perforate. What does perforate mean? Poke a hole in. So perforins, poke a hole in. I know it sounds like a Native American, doesn't it? Poke a hole in? It does.
Like Pocahontas.
Yeah, exactly, like Pocahontas. Right? Maybe Pocahontas was a natural killer cell and they just didn't write a book about her. That's a possibility. Okay? Yeah. Perforins. Perforins lyse abnormal plasma membrane, also attack cancer cells and cells infected with viruses. So it's basically, they're poking a hole in. Literally poking a hole in there. Okay, so recognition and adhesion. NKC, Golgi apparatus, abnormal cell. We're going to bind to it. We have to recognize the cell. Okay? Now, there are two things that are going to happen. The first thing is we're going to do this. Yep, she belongs in the classroom. We can establish that Mimi belongs in this classroom, right? She's like, I'm sick. Leave me alone. Okay, we've established that she belongs in the classroom. So, recognition and adhesion. So recognition. Yep, she belongs here. I know her, I'm not going to get sick. Okay, but she's infected. Oh, man. Adhesion. No, I'm just kidding. So the idea is abnormal cells. First off, we recognize, does she belong here? The second thing is, can we bind to the cell? Yes, we can. That's a matchup. But she's sick, and actually she is sick. Are you sick? You're sick, right? Under the weather. She's under the weather, not sick, not like out of control sick, but she's sick. She's under the weather. So now that I've established that, I can refuse to accept that she belongs here. So what can I do? What can I do? I can attack her. Yeah, I can attack her. Okay? So when it says abnormal cell, does she belong in the classroom? Yes, so we recognized her. Could we bind? Yes, it's a shaking of the hands, that's fine. Is she sick? Yes, can I choose to ignore that she belongs here? I can. Then I can attack her and get rid of her. Okay? She's sick. Lots of soap. Did you know that all soap is actually antibacterial? Even though you buy soap that says antibacterial, did you know all soap? Because it actually prevents the attachment of bacteria. So it's actually an antibacterial. So you don't actually have to buy soap that says antibacterial. It is antibacterial. All soap is. Isn't that funny? Yeah. I like when they do that. That's a selling ploy, by the way. Like, hey, it's antibacterial soap, but all soap is antibacterial soap. Doesn't matter what it is, because it prevents the attachment of bacteria. It's pretty cool. You gotta make sure I'm safe. Get those face mask, achoo, away from me. That's okay, you're sitting next to her. The realignment of Golgi apparatus, so we're going to line up to this cell. Okay, notice what the perforins are doing. Perforin molecules, pores formed by perforin complex. Okay, so notice the MK cell, so we bind to the cell. Okay, we bind to it. So in this case, the binding would have been shaking the hands, right? So we shake hands, and then at that point, I know that she's sick. Her hands are actually kind of clammy, which is one of the signs and symptoms of being ill, being under the weather. Okay, diaphoresis is sweatiness, okay, clamminess. So then we bind, and guess what the perforins are going to do? So in about 10 minutes, she's going to blow up the size of a balloon and pop all over Ellen, which will be awesome. I want to see that. That'll be great. I think you can hide behind Ellen and you'll be safe. Okay? So yeah, lyse of an abnormal cell. But again, we can choose to ignore that because she's ill. There's foreign pathogens in her, so we can choose to ignore that she belongs in the classroom. Okay, so continuing on with the surveillance, well, cancer cells, are those our cells? Yeah, they are. They're just abnormal. They are our cells, okay? Now, but they're identified as abnormal cells. They're totally identified as abnormal, even though they're ours. So again, same situation. I mean, you don't mind if I keep using you as an example, right? Okay, so same situation. She's a normal cell. She belongs here, but she's got a third arm growing out of the back of her head. Okay, like this arm that's trying to grab Ellen. Okay, so is she abnormal now? Yes. Even though we know she belongs here, we can choose to ignore that and attack her. Virus-infected cells, same thing. Okay? Interferons. Now, we've already talked about interferons. What do? They interfere with the virus's ability. Bless you. Oh, and that was all over your shoulder. Oh, yeah, she's going to be sick now, too. This is awesome. I love it when you guys sneeze during the immune chapter. It's even better. Okay, so interferons, proteins, cytokines, which I had you guys underline. You guys had to circle it and underline it. Lymphocytes and macrophages. Cytokines, chemical messengers released by tissue cells to coordinate local activities, to act as hormones to affect the whole body. Okay? So interferons are a type of cytokines. Cytokines are chemical messengers. Okay? And let's go back to this. Linda, I know I caught you at the perfect moment. That was strategic. I did that on purpose. What is it called if you release a chemical messenger throughout the body that's going to coordinate local activities and it's going to affect the whole body? What is that called? It is. Okay, chemotaxis. Now, positive chemotaxis, drawing something towards you. Chemotaxis, the release of chemicals. Okay? And it's going to signal that that part of the body needs help. It needs help fighting off whatever you have. 3 types of interferons. Well, alpha, beta, and gamma interferons. What do? Well, produced by leukocytes. Well, yeah, really, white blood cells. We're talking about the immune system, so that's a no-brainer. But they stimulate, alpha stimulates NK cells. Okay, and we already know that NK cells can do what? They can choose to ignore if you belong. Okay? And there are a couple other cells that can do that too, but for the most part, we'll just fix with the NK. Beta interferons secreted by fibroblasts. They slow inflammation. Okay? And then gamma interferons secreted by T cells and NK cells stimulate macrophage activity. Okay? They stimulate macrophage activity. Okay, so here we go. Alpha, produced by cells infected with virus, they attract and stimulate NK cells, enhance resistance to viral infection. Okay, they enhance it. They basically say, you know what, turn your machinery off because you're going to interfere with it, but we're going to cause a huge reaction. Okay, betas, what are they going to do? They're going to slow inflammation in the damaged area, and then gamma, secreted by T cells and NK cells, stimulates macrophage activity. So someone tell me what the 2 primary, and then the last one, what are the 3 antigen-presenting cells? Dendritic cells, macrophages, and B cells. Okay, so in this case, are we stimulating macrophages? Yes. So we stimulate macrophages. We know that a macrophage is a antigen-presenting cell. So if we've stimulated them and they can actually engulf that antigen, can't they present it to another cell? Yeah. But they also help with the cleanup. Because during any type of infection, there's a lot of damage. Collateral damage, which means our own cells are being damaged. Okay? Foreign pathogens are being damaged, so they're going to go around and clean it up. They're going to clean it all up. Complement plasma contains 30 special complement proteins, okay? So that form complement system and complement antibody action. Complement activation, well, complements work together in a cascade. What's a cascade? Yeah, amplifying cascade, moving down. Two pathways activate complement. Classic, we all knew about classic, right? Like, when we put on the jukebox, we listen to classic music. So this is a classic pathway. We all knew about it. We've heard about it before. How many people have heard about the classic pathway of complement? That's what I thought. Just because we put classic in front of it doesn't mean everybody's heard of it. But there's a classic. And classic just means it's the normal way. Okay? Alternative, which is more appropriate, means an additional, a separate way. So activation, the classic, well, fast method, C1 binds to antibody molecules attached to the antigen. Okay? Bound proteins acts as enzymes, and they catalyze a chain reaction. So what did we say about, now it's saying antibody molecules attached to antigen. Antibodies. So B cells produce antibodies, right? No. Who said no? Okay. Why not? Because plasma cells do. B cells become plasma cells. Plasma cells secrete antibodies. B cells don't secrete antibodies. B cells become plasma cells. Plasma cells secrete antibodies. Okay? So to answer your question, just for clarification, Philip Benson as a child wanted to be a teacher. It wasn't until he went to school that he became a teacher. Could I have taught as a child? No. So B cells want to become a plasma cell to secrete antibodies. Can B cells secrete antibodies? No. Only plasma cells can. Does that answer your question?
So within, it's still antibody, because even though it's natural, it's like
Nope. Yeah, so they have to differentiate before they can do it. So a B cell itself can produce memory cells, but they have to become a plasma cell before they can release antibodies. Okay? So, and this is what we talked about. The classic method is what we talked about. So didn't we say that antibodies would bind to a foreign pathogen? They would bind to it? Well, what complement's going to do is it's going to help catalyze, it's going to speed up that binding process. Whatever that antibody does to that pathogen, it's going to speed it up. Does everybody get that? That's what an enzymatic reaction is going to do. It's going to speed it up. It's going to enhance the process, cascading of events. Okay? So in this case, what's happening is it's going to speed up the process of whatever that antibody does. Okay? And here we go. So antibody binding and C1 attachment. Okay, there's the binding, there's the C1. It stimulates it, C1 protein then acts as an enzyme, catalyzing a series of reactions. Okay? Notice it still says C3b attachment classical pathway. This classical pathway ends with the conversion of an inactive C3 to an activated C3b that attaches to the cell wall. So it's speeding up the process, it's enhancing the process. Okay? Now, complement activation, the alternative pathways, slow methods exposed to antigens, and I'm not gonna hold you to these factors. Just note that the primary pathway, the classical pathway, we've already talked about. What is it doing? Well, ultimately, it's gonna end with the lyse or destruction or agglutination, some type of inhibition of that foreign pathogen. Some type. So what's lysing? What happens with lysing? Yeah, blows up. The cell blows up. Okay? How about agglutination? Clumping. Yeah, the cells clump together. Can they do anything? No. So again, it's these different types of ways that we can speed up the process and help. Okay, so these are slow methods. Okay, it walks you through the other alternative pathways. I'm not gonna hold you to the alternative pathways. I want you to stick with the classical pathway. That's the one that I will actually ask you test questions on. Okay? So both pathways end with the conversion of inactivated complement protein C3 to an active form of C3b. Now, on every single cell, let me come over here. Every single cell, there's receptors, there's proteins. Okay? There are cell receptors and proteins on every single cell. And those have to be matched up. They have to be bound. Now this is an exaggeration. They have to be bound. But can this bind to that? No. No, it can't. So like the video that we watched, a lock and key. The key has to fit the lock. Okay, it has to bind properly. So when we speed up or activate any of this, it's ensuring that whatever's going to bind to this is the right thing that binds to it, the right protein that binds, the right process that occurs. Now, just not to get you confused, but to help you guys with this understanding, we name all these proteins that are found on a cell. We name them all. And every time we figure out a new one, they give it a new name, whether it's active or inactive. Okay? So, is there just one or two proteins found on a cell? No. No. Okay, so the effects of complement activation. So this is what's happening when we activate complement. Pore formation, destruction of the target plasma membrane, 5 complement proteins join to form membrane attack complex, MAC. That's literally like, you know what, this is the beginning of macking it. Like when they mac it, you know, mac, okay, you guys, that's just way too old school, that's like 80s. Yeah, okay. Let's bring it up to nowadays. The Big Mac, does everybody know what a Big Mac is? What does it do to your arteries? It makes them blow up? That works. So, 5 complement proteins join to form membrane attack complex. Membrane attack complex. Well, okay, so let's do an aha moment because we're running a little slow today. That's okay. Here's a cell membrane. It's solid, right? No matter what the makeup of the cell membrane is, it's solid. It keeps what's inside and outside separate. Now, can we transfer water and chemicals, nutrients, other things we need? Yeah, we can. We can actually go out and we can come in without any problems. But it's a fine line, right? We know about osmosis. We know about pores that assist with the movement of specific chemicals and enzymes, and okay? But what happens if we do this? And it says 5, and all of a sudden we create a hole. Now what happens? There's no regulation. There's a hole in the membrane. What happens? Yeah. Either way, if a bunch of stuff comes in, the cell does this. Boom. It explodes. If everything in here goes out, what happens to the cell? Yeah. Without the cell membrane, it's done. The cell is completely done. All right? So what this is saying is that the complement that attaches to the cell, whether it be classical or alternative pathways, the complement, the effects of complement activation, pore formation. It actually makes a hole in it. Okay? Enhancement of phagocytosis by opsonization. Okay? Complements working with antibodies. Histamine release increases the degree of local inflammation and blood flow. So if we have more swelling and more redness and more inflammation and more blood, do we have more white blood cells, more macrophages, more everything we need? Yeah. Okay, so there we go. We just made a hole. Look at all the multiple holes in the bacteria. What happens to it? Kaplooey. Yeah, it blows up. Done. Okay? Enhancement of phagocytosis. What is phagocytosis? What is phagocytosis? Has anybody even looked it up? Okay, what does phagocyte mean? It means be really super quiet. It means that we're being asked a question about something we know. We know this. Cyte means, nice and loud. Cyte means cell. Phago means to eat or engulf. Okay, a process or condition, okay, a process of engulfing, breaking down a cell, engulfing a cell. Inflammation, also called inflammatory response, a localized response triggered by any stimulus that kills cells or injured tissue. Okay? So inflammation, inflammatory response, a local response triggered by any stimulus that kills cells or injures tissue. Where's that? Where's that? You know what's funny is I can't find, there it is. Oh, I know you guys, can you guys see this? Can everybody see this? It's my pinky. It's my pinky, it's my littlest finger. It's the one I love the most. I love this finger. Rawr. And what's on the end of that pinky? It's a cut. And I didn't know there was a cut until I got in the shower this morning. And I got in the shower, and I grabbed my soap, and I rubbed it on my finger, and I screamed really loud, and I woke the house up, and all the dogs started barking, and everybody's like, "Are you okay, Phil?" And I'm like, "Ow! I got a cut on my pinky. It's red. It's inflamed. It hurts. There's swelling. Inflammation, redness, heat, swelling, pain, sometimes loss of movement." Now let me ask you, if I let this go, if I do not clean it out, if I do not take care of it, if I just let it go, like dirty, yucky, kaput, could I possibly lose the movement of this finger? Yeah, it'll swell up like a sausage. I will have a kielbasa for a finger. Gigantic. Can I move my finger? No. Inflammation kills or injures tissue. Is that tissue injured? Yes, it is. Okay? Now, how many times have I mentioned this? A couple? One or two? Oh, okay, a lot. So let's do it one more time, just so you know that I'm serious about it. Crazy. I know. Swelling, redness, heat, pain, and sometimes loss of movement. Swelling, redness, heat, pain, and sometimes loss of movement. Swelling, redness, heat, pain. Now, let's see if they all link up. Is it red? Yes, it is. Is it swollen? Yes, it is. The pressure from the swelling is pushing on the nerve endings, creating what? Pain. So they go hand in hand. Once you start swelling, you put pressure on the nerve endings, causing pain. Redness, heat. Okay, do you have an exceptional amount of red blood cells and white blood cells in that area? Yes, there's your redness. Okay? So, Cardinal signs and symptoms. 3 effects of inflammation: temporary repair and barrier against pathogens. It retards the spread of pathogens in surrounding areas. Okay? It suppresses, it slows down, it inhibits. Now I know that for some of you, you've heard that word and you've heard it in a derogatory sense. Unbelievably, the actual true meaning of that is to suppress, to slow down. Okay? So when you hear that word, please don't think of it as a derogatory word. Think of it as what it truly means. It means to suppress or slow down, to retard. Like fire retardant. Has anybody heard that before? Fire retardant. It slows the spread of fire. Okay? And then mobilization of local and systemic defenses and facilitation of repair, regeneration. So it's all a process. Do we release chemicals? Yes. And as we already found out from Linda, the release of chemicals is chemotaxis, and it says mobilization of local and systemic defenses. So now, because of chemotaxis, we've created positive chemotaxis, and where do the white blood cells want to go? To the area that's inflamed. Damaged tissue, chemical change, okay? Mast cells secrete what? Histamine. Why would they, at the same time, why would they secrete heparin? What does heparin do? Nice and loud. Yeah, it prevents clotting. Do we want the area to clot right away if we need more blood? No, so it's going to actually reduce that. We're still going to have a clotting process, but it's going to slow it down so we can get more blood, white blood cells in that area. Okay, so redness, swelling, heat, pain, dilation of blood vessels, increases blood flow, increased vessel permeability. Okay, clot formation, we do have a clot formation there. Then we come over here, phagocyte attraction. Okay, attraction of phagocytes, especially neutrophils. Remember, they're the most abundant. Okay, they're the most abundant white blood cell. They release cytokines. Removal of debris by neutrophils and macrophages. Activation of specific defenses. And notice that's by itself. If we need it. If we need it. Because if we can control that infection with macrophages, do we need to activate all your T and B cells? No. Not at all. This is still part of non-specific defenses, so we don't actually need your B and T cells activated at this point. Now, production of inflammation, necrosis, pus, and abscess. Okay, everybody say it. First word, necrosis, necrosis. Local tissue destruction in area of injury. Just means death of tissue. Yeah, death of tissue. Coming to a movie theater near you. Friday, 11 o'clock showing. Nice. Death of tissue. That's like a straight up scary movie. Can you imagine that? I could make a scary movie of something that gets on you and starts eating your tissue away, and it only happens at night, and it's raining half the time, so it spreads easily. And there's a girl that falls down in the middle of the movie because it's chasing her, and the music's loud, and then she gets up and falls again, and it's like necrosis is coming to get her. That'd be a great movie. I could do that. Yeah. Anybody want to play the girl that falls down? Adam, did you just raise your hand for that? He's like, I got this. I'll be the girl that falls down. Nice. Yeah, pus. Oh, pus. Such a fabulous word. When you say it, say it. You can't even say it, like you're afraid of saying it.
That's like white stuff.
Yeah, it's the white stuff. It's that horrible white stuff that you're like, oh man, oozes all over you. Attacks your friend. That's going to be in the movie too. Okay? It's a mixture of debris and necrotic tissue. So it's a mixture of debris and dead tissue and fluid and just everything. It's a collection of happiness. Okay? And in one sense it's good for you, and in another sense it's bad for you. Okay? The good sense is that you're actually doing something. The bad sense is that it's still there. If you still have an abundance of pus, that means you still have something happening. Okay? And then the last one, abscess. Pus accumulates in an enclosed space. Okay? Yeah. This is where you're like, what is that? Did everybody see that YouTube video with the guy that, it's on his back. Have you guys seen that? where he has like an abscess on his back and the doctor goes and like punctures the abscess and starts squeezing and his whole back is filled with pus and he keeps going like this and it keeps shooting out his back. It's like this flow of pus and redness coming out of his back and they keep like 20 minutes of squeegeeing pus out of this little hole on his back. Yeah, if I can find the video, I'll show you. Oh, yeah, pretty grody. Like they had to put a towel around his back to contain it. That's how much pus was coming out. Yeah, pretty. So it came from an abscess. Yay. Okay, fever. We talked about fever. Okay. Maintain body temperature above 37.2 for those people that don't live in the U.S. 99 degrees for those people that do live in the U.S. Okay? Yeah. So, fever. And what was the number I said was kind of the maximum? 104. Yeah, 104. 105, you're killing your own protein. But 104 for adults, yeah, keep that in mind. Children, we panic a little bit more with children. That's one of the ones that we just, 99.9, you're like, quick, give them something. Yeah, I know. Okay, pyrogens, pyro, heat, flame, fire, pyro. Okay, pyrotechnics, pyromania. Okay, yeah, pyro. Pyrogens, gen means to produce heat. Pyrogens, any material that causes the hypothalamus to raise the body temperatures, circulating pathogens, toxins, and antibody complexes. Notice it says antibody complexes, which is assisting with the non-specific defenses. Okay? And then endogenous pyrogens and interleukin-1. Didn't we have an interleukin-7? We did. Remember I told you there was going to be a whole bucket load of interleukins? Yeah, now you have interleukin-1. Interleukin-1, pyrogen released by active macrophages and cytokines. Okay, interleukin-1. Now we have interleukin-7. Now we have interleukin-1. Now, okay. We're right where we're supposed to be. We're not caught up by any means. Please don't think we're caught up. We're not. We're so far behind right now, we could use this entire period with lecture. Okay? So, but we just finished non-specific. Notice the one thing I said when it said activated immune response, I said that it could activate B and T cells. But because we're in non-specific, we're not going to. If we have to activate B and T cells, what do we become? Specific. B and T cells are very, very specific. Now, please keep in mind that non-specific defenses activate, they stimulate specific defenses, if needed. If you get a little cut right here, and you clean it out, inflammation's still there, a little bit of redness, a little bit of swelling, some movement of macrophages, some neutrophils, and you're good to go. But if it gets out of control, or let's say you get it in your throat, do we have to activate specific defenses? We do, B and T cells. Okay? So, let's. This would be a good time for me just to stop this.